The third rule is the quotient rule. So we saw when we have two functions multiplied together, what happens if we've got functions divided by each other? What do we do? Some people like to turn it into a product rule question by using negative indices. See, okay, you could do it that way. Quicker, though, to use the quotient rule, which looks rather strange. U divided by V, there's our two functions. You can see the formal answer there. VU dash minus UV dash on V squared. No. Square the bottom, write down the bottom, diff the top, minus write down the top and diff the bottom. Okay. So square the bottom, write down the bottom, diff the top, minus write down the top and diff the bottom. Say it as you do it as you say it. It'll get stuck in there. So x on 1 plus 2x. Square the bottom. That's the easiest bit of the whole thing. Whatever the bottom is, put parentheses around it and go squared. Done. Square the bottom. Now everything else happens on the top of the fraction. Write down the bottom. Diff the top, which is just 1, minus, write down the top, diff the bottom, which is 2. 1 plus 2x minus 2x, I just get 1 on 1 plus 2x all squared. Let's try another one. 2x on the square root, oh, you know what's now going to happen, square root of x squared minus 4. Square the bottom. Well, when I square a square root, I get power of 1. So it's just x squared minus 4. Write down the bottom. X squared minus 4 to the power of half. Diff the top. 2. Minus. Write down the top. 2x. And what comes next? Diff the bottom. Okay, go on. Diff the bottom for me. So half x squared minus 4 to the minus half times 2x. All right, let's tidy this up. Okay, 2x squared. Common factor on the top of, well, there's a 2. There's also x squared minus 4 to the minus a half we could factorise out, but because it's a negative power, we put it on the bottom of the fraction. There it is, our super mathematician answer. X squared minus 4, square root of x squared minus 4 on the bottom, negative 8 on the top. So, we now have chain rule. Bring down the power, lower the power, diff the inside. Product rule. Write down the first, diff the second, plus write down the second, diff the first. And now, quotient rule. Square the bottom, write down the bottom, diff the top, minus write down the top, diff the bottom. One more to go. I'm going to let you in on a little secret. Reciprocal rule. Where this is handy is if you have a constant on the top of the fraction. So rather than doing the whole quotient rule, because if the top is a constant, when you diff the top, when you get to that part, what do you get? 0 is correct. Differentiate a constant, you get 0. So to save time, we can do this. Minus the derivative on the function squared. Always multiplying by the constant that happens to be there, if there is one. So 1 on x squared. Yes, I could change it to x to the minus 2 and do it that way. But I can just go, minus the derivative on the function squared. Minus 2x on x to the 4, x's cancel. Minus 2 on x cubed. Minus the derivative on the function squared. So if it's a 6 on the top rather than a 1, I still do minus the derivative, but I multiply by the constant. So minus the derivative is 8x on the function squared, minus 48x on 4x squared plus 3, all squared. Reciprocal rule. Minus the derivative on the function squared. So we now have 4 rules. I should be able to pick anyone at any time. I could stop you in the street if I happen to see you and go like this. Quotient rule.